Thought I was recording, but it wasn't. Sorry. Sorry. There were multiple sizes of collets for the 3A, GHA 3A. Like I said, I've got well, I've already gone over this. So I don't have to go over this. I can just start making this part. I've already, you got disaster struck. What do you do on your channel? I make mistakes. I make stuff. Like what? Like mistakes. Hi. Hey, everybody. Adam Savage in my cave with another project for the pantograph route miller. The official name for this is a GHA Alexander Model 3A die sinking machine. Die sinking! There's another YouTube channel which says that's German for boat anchor. There are other videos about this. We'll include links in the description. I purchased this on Craigslist from a local seller who the previous owner of this used to make pen nibs and engrave them in an incredibly fine detail. And it came with very few of its original attachments. It came with some excellent ones, but one that it was missing was the collets. It only came with a single collet. This is a collet. A collet is like a drill chuck. And you can see these radial slices in it. And you can see how one goes all the way through and the other five go almost all the way through. That is a bending scheme to allow when you pull this collet, when you push this collet in, it grabs whatever is in there. Hold on, my phone's ringing. The spindle of this, which holds the cutting bits, the engraver bits, the round-ended bits, the bits for engraving and carving and machining and removing of material. There are several thicknesses of those bits. And this model, 3A, is supposed to be able to handle up to 5/16 or even 3/8 bits. However, it only came with one that is 1/8 of an inch, 125 thou. Roughly 3 millimeters plus a little bit. Boy, can you get into trouble with 1/8 bits and 3 millimeter collets. That being said, the collets for the GHAs, the Alexander pantographs, all you can find online about the collets is metaphors for how rare they are. Hen's teeth, needle in a haystack, unobtainium. And so I have done a little hardness test on these. This isn't a hardened collet, although it does look original. And I have some 4140 steel, and that should be ideal. That should be an ideal toughness that I can make some collets that I don't have to harden and grind. I can get them really close. Making collets. This feels like an advancement in my education as a machinist. This is something that like 5 years ago would have been like, absolutely not. But you know, you watch enough of Stefan Gottswinter and you're like, I might not be that tall, but I might be good enough to do that. He's given me inspiration. So, collet making. Well, first thing we're gonna do is we're not gonna trust the drawing for this angle. We're actually gonna measure it and dial it in on my cross slide, which hasn't been mounted to my lathe for a couple of years. So here we go. Oh no, that's what I want. Great. I always try and disengage this before I get close to it, putting a chuck in. Don't tell me your lathe stories in the comments. I don't want to hear them. No, not this one. I'm wrong. I want to do it different. Am I right? Am I right? Am I wrong? My ER 32s here are not as accurate as I would like them to be. They're fine for the prop work, but I bought some much more accurate ER32s and an ER32 holder but I'm going to put it in a much better chuck. So we're going to pull this one back out. 1, 2, 3, 4, 5. You see where I get my cardio from. I remember when I first put this chuck in, it ran only a couple of tenths out of round. So we're going to put, let's see how wide a jaw can contain here. Boy, are these little chuck inserts hard to find and expensive when you do. I think I've got a high spot that's about 2 thou. Yeah, it's just about. It has to take the high spot down. So I'm going to throw I've got some stainless steel sheet material, shim material, and I'm going to slip a 1 thou shim into this little, and we'll see if that helps. Hey. Holy cow. That brought it within, yeah. That brought it within half a thou. Yeah. 12 microns or so. That should be acceptable. Okay, so let's back up from there. That's going to be as good as I get there. So let's just see how good this one is. Why not? All of this is so that I may actually just get this angled really, really nice and tight. Great. Captured here, I'm within 10 microns. Okay. So now, God, I love shim stuff. Longer one in there. Wait. Could just be sitting in here. Could be, but it ain't. Great. All right. So this is how this works. We pop in my multi-fix. And what we're going to be looking for is to match the angle of the collet with my cross slide. So the first thing to do, is actually to oh, right, because the mark is over here. Oh, for crying out loud. For crying out loud. Tape mark. We're going to make a little mark. So I don't need this in there just yet, because what first I need here paint this guy. Because all right, I know this rig was a little bit wonky, but I'm feeling pretty good about it. If I don't, you know what? I'm gonna measure. Yeah, I like that. Okay, so I think I have this locked now. I think I have this at the correct taper. Let's pull this all the way out. Let's tighten this one up too. We'll get all three. Okay, great. So now, what I want to do is I want to I have to admit to you, I did not expect to have good news at this point in the build. This is the first time I've ever tried cutting a really accurate taper. And so this is the collet that I'm starting from. You can see the surface finish isn't amazing. It's fine. This is the ground surface finish of mine, which is actually even a slightly better surface finish. What I did was I colored it with Sharpie, and then I stuffed it into the spindle, and I'm getting a really nice wear pattern that is exactly what I want. It's touching both top and bottom. Now, I suspect there's a little relief inside that matches the relief here, but that's beautiful. That tells me I'm on the right track. So now I have to come up with an order of operations, right? Because here's what has to happen with these. They've got to get turned to the outer critical dimension. Then they need to get turned to their taper dimension. Then the question is, in what order do I cut this little here and then cut these, then do the slots for these? And then what do I do about drilling those? Here's my idea. I could get very much lost in the weeds here trying to get within, a few microns, really, really crazy accurate. But to be honest, even a little bit of slop here works in my favor because as I've said, the pantograph gives me a kind of a slightly analog copy that shows its analogness, and that is what I wanted. So I've got some, this is 4140. It's got a very nice surface finish. So what I'm considering doing is actually, I think what I do is on a bar here, I rough out 1, 2, 3, 4, 5. I mark them out and I spend time on each of those cutting and grinding the 4 tapers and getting these dimensions fairly close. Then once I have those all ganged up on a single bar of 4140, I chuck that into the rotary table on my mill and I cut 6 slots, but I do not cut this one. I don't cut the one that goes all the way through. I cut all 6 slots. Oh, wait a minute. Wait a minute. The reason I stopped is because the slots aren't the same depth for all the collets, right? You see the slot's relationship to the hole? They're all going to have the relationship to each of the holes. So each slotting and drilling operation has to be separate, but I need to be able to hold on to this thing. So I think where I hold on to it is here. I think I make a plug that comes out of here with a nice roundness that allows me to grab that with great gusto. And then I can drill the drill and cut the slots for each one. Okay, so it's, I think my original plan of ganging them up 6 on the bar makes sense. Cutting and grinding them, I'll get them. I'm happy with that. That's plenty for me. I can even throw some lapping compound in there and make a little, and bring it all into its orientation. Maybe I'll make this my backup 1/8 inch and I'll make mine. Plus I can also then go in with some metric reamers and do, 1, 2, 3, 4, 5, 6 millimeter. Yeah. But let's bound this problem. Let's bound this problem in the imperial space for right now. I have a proof of concept. I'm excited about how this can go. I'm going to make a list and start checking it twice. Here's where we're at. I believe I'm super close on these. I don't think I'm dead on the money. I don't think I'm in Stefan Gottseventer territory here. But when am I ever? When will I? I don't even think I'm in inheritance machining territory here, but I'm close enough. So, look, the big issue with collets, one of the big issues with collets, I don't have to yell it. One of the big issues with collets is that they often, for dimensional stability, should be hardened depending on what you're doing with them. And when you harden stuff, it warps. Hardening is most often a process of taking something like this and heating it to a certain temperature and then quenching it in a thing that slows its temperature down at a certain rate and causes an internal characteristic to be generated that yields a kind of strength, yields a specific amount of tensile strength and ductility. And if you're going to harden a collet, there's a pre-machining phase and then a post, usually grinding phase. I am not going to harden these. I'm going to work on the assumption that 4140 is a nice tough steel, that it should be dimensionally stable enough for my little needs on this. So I'm going to make, what am I going to make here? I believe I'm going to make Hang on just a second. So my primary thing is I have a bunch of these little carbide end mills. My hair is spectacular this morning. Getting a lot of secondary motion, Muppet motion from my hair today. But you always knew I was part Muppet. This shaft is a... See, I don't know what's going on here. I put a 124 thousandths gauge pin in here, and it fit perfectly. I got a 124 thousandths shaft, and it's a tiny bit tight. At any rate, I got a bunch of these true 1/8 bits, and this feels like not quite. It feels like a 3 millimeter, not a 1/8 bit. There are no markings on it. And when I say it feels like that, I mean like my Nakanishi here. This is a true 3 millimeter collet, which means you genuinely can't get a 1/8 inch bit in it. You can, but you can't sink it all the way to the bottom. Oh, believe me, I tried. That's why I had to separate all my Dremels out to 1/8 inch and 3 millimeter and make them really sacrosanct and separate. So this is going to be turned. I'm going to make a separate true 1/8. Then I think I'm going to make a 1/4. I don't feel a driving need for a 16th because I can buy end mills with an 1/8 inch shank. And I can see wanting a 1/4 inch. So I think what I'm going to do is I might prepare 4 blanks. That gives me plenty of chances to mess up. I'm going to prepare 4 blanks. And the 2 most critical are 1/8 inch and 1/4 inch. And I guess I could do 16th and 3/16ths if I wanted to round it out. Sure. Really, I just want to... I'm excited about this exercise. The other thing about being really close on this is that, like, when I say close, my feeling is, messing around with these materials, that the dimensionality of this taper is within, I'm going to say, 12 microns of the critical dimension of this, in terms of it's within a few tenths of this perfection. But this conforms, right? The 6 radial slices means that there's only a tiny amount of steel being bent, and it's conforming to the hole, so it should be self-centering. That makes me all feel pretty good about making these and not hardening them. Maybe I should prepare more than 4. All right, 6 blanks. 6 blanks. Let's make some collets. All right. Oh, no! Bah! No! No! Oh, that's useful. Okay. Another mystery. Look at that. Oh. Another thing. Great. Oh my God, there's so much down here. Look at that. That's really useful. Clearly, I've been neglecting it down here. All right. I fell down this way. You know what? Yeah. Yeah. A moment of impatience. 5 minutes of dirty. That's how this works. 5 minutes of getting dirt. Woo! All right. I got fooled. Look how close that is to what I was looking for, but it's actually one of the extra tips for one of my live centers. Okay, so now that my 6 blanks are produced, I'm going to swap out the chuck. The thing about these chucks, here, let me just show it to you. These chucks have these are wonderful. They have a huge amount of dimensional stability. And I like them for that. But you can't just grab something at the front of this because these seat in a taper. You've got to grab past the halfway point of that taper. Otherwise, these separate fins, which all like sort of float within a spring arrangement, will not necessarily be grabbing your work concentrically. So I'm going to swap this out for the 6 jaw. For the 6 jaw? Yeah, I don't even want to grab this with the 5C, with the... Wait a minute. I could potentially grab it with the... Yeah. No. We're gonna go with the 6 jaw. The reason for that is that I can dial in the 6 jaw to be very, very precise concentrically with the outside of this stuff. And between that and knowing that these holes are very close to really, really on center, that should get me where I want to go. Ladies and gentlemen, that is within... Oh, yeah, I like that. I've gotten that within 3 10,000ths. Since each 10,000th is 2.5 microns, 3 of them is 7.5 microns. That's only slightly bigger than the diameter of a red blood cell. Isn't that cool? All right, so I like that. We're going to raise that up. We're going to move this over to a safe spot. We are going to lock this puppy down. this mother out. All right. And now, so this is how this kind of chuck works. It's called a true set chuck. And now once I have set this to be really dialed in, it will remain really dialed in for this diameter. If I change my diameter, I'm going to have to redial it in. But you see how fast that was. This is. I want to thank Tom Lipton. I want to thank the Academy, and I want to thank my mom. I want to thank Tom Lipton, specifically from Oxo Tools, for telling me, go get a 6-jaw chuck, make that your bread and butter chuck, because it holds things with twice as many fins as a 3-jaw chuck. It's just basic math. So it holds things more gently, but more securely. And with the true set, honestly, you know, that kind of chuck's not cheap. I think it was well over a couple grand, which was the most I'd ever spent on a chuck. But since, I mean, this whole machine was like $3 grand. These machines, some of the value you can bring back from them is because they're so heavy to move around, right? But anyway, this was totally worth it in terms of what it added to my process and speed. Okay, so now, I should be ready to start grinding some basic tapers, right? Yeah, I think it's time to start grinding some basic tapers. Let's do it. We're back to Collet's. Good morning. You don't know that it's morning, but it happens to be. You can tell by my spectacular morning hair. So, Collet's proceed. I have ground this blank. Look at the focus trying. There we go. I have ground. No, hold on. Sorry, I was trying to shoot that in cinematic mode. That's crazy. So I have ground a blank. I have 5 more blanks. And I have cut this with an insert tool, and I've also ground it with my tool post grinder. If anything, I've gotten a better finish than on the original Collet. It's about the same kind of garbage finish. I've also measured this in every way that I am capable of here to my satisfaction that it will work as a Collet. The proof will be in the pudding, and I won't know till the very end of this procedure. But the next step is I'm going to cut all of the other 5 blanks to this taper, and I'm going to grind them all. Once I have that all done, then it will be time to move on to the next operation. many steps. So, want to see something neat? I got all 6 blanks here. Oh yeah. Yeah, 6 blanks. Now we are going to, I need to work out about how I'm going to cut these. I'm hoping I can do it the way I'm thinking. So I need to put my dividing head on this machine. I might not be doing the slicing operation just yet, but I kind of need to know how to do it because it looks like to me, okay, so these collets that I'm making need to be perfectly concentric. That sounds obvious, but it is like concentricity has to be maintained. And to that end, what I need to do is I need to figure out what sizes each of these are. 16th, 3/32, 1/8 inch, 5/16, 3/8, etc. And then I need to drill and ream those true holes. Right, that is the next thing that I need to do. I need to drill the correct holes in the center of these collets that I'm using. Because I won't be able to make the slices until I do that, because the slices, as you see, they come quite close to the actual hole, and since the hole size will change, so will the depth of the slices. But I am not positive, 1, that I have the right slitting saw, or 2, that I have the correct arbor for it. So I might need to make that. So I'm gonna get the rotary, I'm gonna get my dividing head set up here in the mill. And get it trammed in just so I can see if I get the relationships that I was hoping to get out of this. That's the next step. All right. It's order of operations, man. Order of operations is everything. Well, yeah, so we'll see how this all goes. I gotta drill the correct holes now. I might not have left myself enough on these to do the slicing I need to do with them, which is annoying, but I should be able to do all the finishing cuts on these. Yeah, I should be able to do all the finishing cuts on these. I just need to get some cutoff wheels. So I'm going to work on doing the finishing cuts on these 6 blanks, drilling their true holes from the front, and then we'll get down to the slicing and the dicing. Here's hoping. All right. I'm always doing this with materials. I'm frequently not giving myself enough room. Here's the trick. I need to make this slice, and it has to go all the way past that last ridge, because that's still part of the collet, which means that in the space of this saw needs to be able to come down to there. And you see the issue I have is that yeah. Hang on, my phone's ringing. Collets. I didn't leave myself enough room on my blanks. That's fine. I can make more blanks. I have more of that steel. I have enough. But before I go and cut more steel, I did a precise center drilling on these two pieces and connected them with a dowel pin and some Loctite about 90 minutes ago. And now I'm going to chuck them into this, and I'm going to do this cut. I'm going to do this cut with my hair is just something spectacular. I'm going to do this cut with the slitting saw, and we're just going to try it. I'm going to see if I can get there. What's really going to happen is that I'm going to do 6 cuts, but they're all going to be like the 5 cuts here. None of them will go through. Then I'm going to disconnect it from its mooring with some heat. Then I'm going to drill out the center hole, the true center hole, which will be an 1/8 inch hole. That's I'm looking to replicate this, but make it a true 1/8 inch collet, not a 3 millimeter like this. Yeah, I think I've roughly explained what I'm thinking about. Let's get to it. I'm wearing a hat because I can't stand to look at my crazy hair today. I really messed that one up. Let's tally, shall we? I made 6 blanks. That one I didn't quite get far enough. I tried that on a 16th inch end mill, which snapped so quickly. It was like a magic trick. It was just gone. Then, I don't know what I was thinking, but that hole's not on center, so that part's garbage. And then there's the one I just messed up. And again, messed up is a relative term. I have not made a collet before, but I now understand all the parameters. I turned that thing in the wrong direction. What a dummy. What an idiot. Anyway. Hopefully I haven't overly dulled this blade. I have a second one should I need to. Okay. Okay, so I have a true 3 millimeter collet here. I'm going to make a true 1/8 inch collet and a 1/4 inch collet. Out of this 4140 steel. I'm going to do this all as one operation? No, I am not. All right, so that then comes here and I can, I've cut this garbage surface finish here on the taper. I'm so sick of these collets right now. I'm so sick of them. Oh my God. Yeah. So I'm going to put the tool post grinder mounted into the tool post here and do a grind on this. Then I'm going to do the relief. Actually, I can do the relief now and then I'll do the grind. And then once I've got that, I'm going to do all the finish drilling on. Disaster struck. I finished the collet and I wanted to drill it out. So I went with 7/32, 15 thou shy of 1/8 inch. And I was going to ream it with 1/8 inch. And then bit broke inside. However, I think I was at full depth, which might mean if I cut the relief fins out of this collet and then slice it on the lathe, that I should be able to pop out the drill bit and maybe re-drill it. I don't know. We're gonna have to see. I'm sick of collets. Can you tell? I'm stopping because I'm impatient and I'm about to make a mistake again, and I want to talk to you about this mistake. So, everything I just did, I have to redo. Up, out. Excellent. Okay, so when you mount a slitting saw into an arbor, obviously you can choose which direction the blades go in, right? And what I keep forgetting is that the blades should travel for a top-down clockwise cut. And the reason for that is, I don't have to do that. My milling machine has a forward and reverse. And because it's a three-phase big-ass motor, you can go forward, you can just turn it in reverse, and it'll and turn back in the other direction. So it goes both directions. Why do I need to change the direction of these? Because most of my cutting is done with normal milling bits, which cut forward. And so if I chuck this in backwards and I don't remember that it's backwards, then I burn it out right away, which I did already. That's how I burnt out the first of the slitting saws on this. So I'm taking it out. I'm going to remount it upside down so that it gives me that clockwise milling cut. This is not a completely vital change. This is this is me knowing my proclivities and like making sure I don't make a dumb mistake. So clockwise, clockwise, clockwise. There we go. I'm also going to mount it farther up the arbor. The farther up, the farther into the spindle you can mount stuff, the better your cuts will be in general. So it's just like a rule of thumb. It's better to be up here than it is to be down here. All right. In. And let's get out the big condenser. Excellent. All right. Now we bring this down, and when I cut forward, it cuts like it should. Okay, so let's do the same thing we just did, which is to line up my cut. I'm gonna have to look it up, but I think I work hardened my 4140. I'm going to try and make a cut on the backside of this. I'm going to scrap this. The good news is I'm getting closer. And the only reason I'm still banging away at this is because once you set a taper and lock it, it's set. So I can keep on, in theory, doing this. And I know I've got a bright affect right now. It's no fun to keep on spinning my wheels, literally, and not getting anywhere. And right away, I also appreciate all the comments of the former collet makers in the comments. Thank you. I know you are commenting, if only just to, either or tell me to go with God. Yeah, but it's annoying. I'm annoyed. Slitting saws, I always have a little bit of difficulty with them. I think I'm right. I don't think I've burned this slitting saw out. It still feels crisp, but I've learned the 4140. I've learned my limits with it. Today we settle all the family business. All right. I got a Demon Core project on its way. I'm going to need to use the lathe. I'm going to need to unseat my cross slide here, which is set at an extremely precise taper. But you know all this. You've been watching the video. I was going to make a set of collets for my pantograph mill. I was going to make like 5 or 6. I'm going to make like 2. 1/8 inch, 1/4 inch, 1/8 inch, 1/4 inch. That's all I'm making. I don't think I need anything smaller than 1/8 inch. I've got 3 millimeter. Need 1/8 inch and 1/4 inch. That's it. So I'm cutting a taper. I've got some new inserts. I've got some new TNMG 164008-ZTM, and they're already given a nicer finish. So yeah, let's make some chips. All right. This is the last cut. It's not the last cut. This is the last slice in my collet. It's worth talking maybe a bit about how cool collets are and that they exploit both steel's hardness and its flexibility at the same time. For the uninitiated, just in case it's not super obvious, these 6 slices into the sides of the collet allow the collet to grab a bit. And they do that because one of the 6 slices goes all the way through the center. And that allows the whole collet body to grab the bit that you put into it. So its ductility, its flexibility is important, but its dimensional stability, i.e. its hardness, is also critical. So hopefully when I finish mine, I'll be able to get it to do what I want, which is to hold that 1/8 inch bit concentrically in the pantograph router. Okay, this is the last cut, and this is the cut I'm going to go all the way through. So I'll cover it from the front so you can see it happen. And, you know, if it craps the bed, we'll be there together. All right, here we go. The last operation I did was to, the distance between the end of these cuts and the center was about 20 thou, and I had it at about 25 thou. Again, 1 sheet of paper difference, but that could be enough. So I went in and removed that last 5 thou. Now, before I take the collet blank out of my indexer, the next thing I need to do is to mill these 2 flats. There's a flat here and a flat here. And the flat is just milled to the internal diameter of the little cove here. Cove, it's not cove, but anyway. I've just got to cut that flat. So that's what I'm going to do. That might be my collet. I'm going to ream that. Shockingly, the one on the right's the new one, and it looks pretty good. That's the old one. That's the original. I feel like my surface finish is even a little bit better. Collet done. Let me get an 1/8 inch something or other. I'm using this 1/8 inch roto zip, which is a hard press fit into the 3mm collet. But after a little finessing with the reamer, it is a perfect fit. This will way open up the possibility of what I can run in that machine. I want both 3mm and 1/8 inch. Let's go put it in and see if it works. So, I have mic'd it. That is, I've taken my micrometer to it, my Mitutoyo 1/10 thou micrometer, and I'm getting now about 1.5 thou of run out. That is 1.5 thousandths that this moves. What is 1.5? What is 1.5 thousandths? It's slightly thicker than a cigarette rolling paper. It is about the 1/3 of a sheet of paper. It is enough for me to utilize this machine. Turns out the real friends we made were the people we met along the way. It's been a journey. Thank you for joining me on this. Now I have two GHA Collets. Yes. If you happen to have any in your collection, I will make you a trade. But I feel like a collet is a literal expansion of my skills. You see what I did there? I'm very, very happy. And also that was exhausting and grueling and a real pain in the ass. I'm going to move on to some other builds. But now I've made my first collet. And I want to say when I first tightened it in, it was about 3.5 thou of run out. And then I tightened it, which should pull it all in and increase concentricity. And it did. I love it when my expectations match my reality. So 1.5 thou. Actually, it's not even 1.5 thou. It's just slightly less than that. I'd say it's about 35 microns. Okay, I am done talking tiny increments. I'm gonna wrap up and make an easy to make part. That'll be a fun build. But sorry, not on this. This is just, we now have proof of concept, proof that this works. I'm super psyched. It's much more functional now that it has an 1/8 inch collet for it. This build's gone on so long. I feel like I need to do more of a tie, but I guess I don't. All right. Thanks everyone for joining me on this one-day build, and I will see you next time. I can't believe you stuck it out till the end. Well, now that you're here, let's talk about some of the cool stuff we have at adamsavage.com, our merch site. We make stuff for makers, and one of the most important tools a maker possesses is, of course, their laptop. That's why this year we are making 2 laptop sleeves, a large and a small, to protect your precious cargo. Like all of our products, they're made of upcycled materials, manufactured in the United States. And on each of these models, we have included a new feature, which is like my new favorite thing in the world, is this pencil holder with a rubber stamp of my name here. This is inspired by the NASA astronauts' name labels on the Apollo astronauts. And there's one on both sizes. Get yours today at adamsavage.com.